Hi, everyone, and welcome to the AWS Resilience and Chaos Engineering Day live Q&A. We're coming to you live, and my name is Gunnar Grosch, developer advocate at AWS, and I've been with you throughout the entire day, starting off earlier this morning with the keynote, and then we've had 5 other great sessions throughout the day. And joining me in this live Q&A are 3 very well-known people in the resilience and chaos engineering field. We have Seth Elliott, we have Jason Bartow, we have Adrian Hornsby joining us. So hi, fellas. Thanks for joining me.
Hello.
Yeah, happy to be here.
So Jason and Seth, you had sessions earlier today, but if people didn't catch those and your intros, let's do the introduction part first. Seth, go ahead and tell people.
All right, I'll go first. Sure. My name is Seth Elliott. I'm the Principal Reliability Solutions Architect with AWS Well Architected. If you heard me talk about what Well Architected is. Been with Amazon for about 10 years. I've worked with lots of big customers, but my previous gig before joining AWS was working with Amazon.com, the consumer, on their AWS adoption strategies.
Thank you, Seth, and welcome, Jason.
Hi, good afternoon, everybody. Jason Bartow, I'm a Principal Solutions Architect with AWS, working here in London, working primarily with our larger financial services customers.
And then finally, Adrian joining us. You didn't have a session today, Adrian.
Yeah, I'm just sneaking in, just cool. But yeah, I'm Adrian. I'm a principal technologist with the FIS team in the EC2 organization. Mostly working currently at making sure FIS is successful, getting my hands dirty as well, coding there, and working with customers, helping customers build resilient and scalable application, and also how to adopt chaos engineering practices and things like this. Been interested in chaos engineering for quite some time. Built a bunch of open source tools, and yeah. Wrote quite a few blogs around chaos engineering on AWS as well, and yeah, so it's good to be here, and good to see the succession and so many cool people talking about chaos engineering. It's really awesome.
Yeah, it's been really cool to finally do this day as well, to be able to bring a lot of knowledge around chaos engineering out to users. So we've received a bunch of questions throughout the day during the different sessions, and we'll try to address some of those during this Q&A. But also, if you're watching this and you have questions around resilience, around chaos engineering, post your questions in the chat, and we'll do our best to answer those as well. And I want to get started with a question that has been brought up quite a few times, and that is how to get started using chaos engineering in your organization. We've had several sessions now talking about how to practically do chaos engineering, but how do you get started within your organization? Who want to go first? Seth, go ahead.
Yeah, well, I try to address this in my talk. It's actually the talk and the lab that goes with it is meant to help you drive that conversation in your organization, because the lab is meant to show you how you can do chaos testing and chaos engineering using really simple tools, not having to buy anything, not having to use any black boxes, using either scripts you write yourself and then advancing eventually onto FIS, so that you can show your management that this isn't some sort of magic, this isn't some sort of dangerous thing, this is something under your control, and just like any other tests, it can be created and monitored by your team.
Adrian, Jason, you want to add something?
Yeah, I can talk a little bit. I mean, it really depends on the organization. I think there's many strategies, whether you're a startup, small companies, or a large company. The people driving chaos engineering might be different. But I from an individual standpoint, I think there's a similarity, and it starts with being curious, right? And I think curiosity is what starts all conversation, and being curious around some of the assumptions we do and some of the things we might take for granted, or things that we are uncertain. For example, I love asking customers, like, what are you worried about? and that's a great start of a conversation. And typically developers and system administrators or SRE teams, they always worry a little bit about something, and taking that step further and discussing it, making an hypothesis is already very interesting. And you'll see people have different answers to any hypothesis, and then going even a step further and going verifying it, I think is as simple as that. And I think it really starts by that, asking those questions. What are you worried about? And then the second one is, what are you not worried about? It's simply because most organizations are also a lot of biases, right? When things have been running or expected to be running, or we haven't detected those errors because we lack monitoring of alarms. It's also a great question. What are the things that have not barked in the last 2 years, 3 years, and maybe go verify that actually they really do what they're supposed to do without hidden issues, right? I think those are interesting things to start the conversation around chaos engineering.
Yeah, just to add a little bit more to that, Adrian, right? Like you said, what are you worried about? But also more importantly, what are you not worried about? I think up until quite recently, we would have looked at parts of our architecture like a content distribution network and thought, yeah, we're using a CDN, job done, right? But we've started to see outages where large reputable CDNs have had disruptions to their service. And so we've got to start to ask those questions about what could go wrong, hypothetically. What could go wrong? What are the hypotheses that we should be testing using chaos engineering, and then start to pull those into our experiments after we start to take care of and start to develop the chaos engineering practice within our organization. The other thing, working with a lot of large enterprise customers that I find some people have trouble doing is having a test environment. If you think about the Netflixes and so forth, they oftentimes talk about running chaos engineering in production. I don't think anybody on this panel would suggest that you do your first chaos engineering experiment in production.
Not your first, but
no, not the first.
Yeah.
But so have a test environment, right? Have a safe environment where you can deploy your application, where you can put it under a steady state load. Have a load generator that you can apply to it, and have probably some downstream stubs as well that where it has dependencies that you don't need to connect to those live systems. So it's not just having the tooling and technology such as FIS or even having the hypotheses, but also having an environment in which to do those experiments.
And just to add something, I think a lot of people also confuse fault injection with chaos engineering, right? Fault injection is just one part of chaos engineering. I think what has been way more interesting with customers and all the teams I've worked with is what led, the discussion that led to the fault injection. So discussing the hypothesis, and trying to figure out if everyone agrees on the hypothesis and what it should happen, and then once it runs, and go and understand the results and dive deep on the result and trying to understand what really happened. This is the before and after for me is way more important. Fault injection is really just one small piece, right?
Yeah. Go ahead.
Yeah, just going to say that I tried to address that a bit in my first session, talking about the phases of chaos engineering, that the experiment part is just one of those phases. There is just so much you learn by going through the process, from identifying what you can test on, creating that hypothesis. And even the first phase, just getting to that steady state, knowing the steady state of your application. I think that's something that a lot of companies or people working in different organizations, they don't really know what the steady state of their system or application is.
Yeah, so if you saw this slide that I'm sharing now, I stole that from Adrian. So that seems relevant to what we're talking about now. So, okay, I didn't know if it takes... All right, yep. So that's exactly what we're talking about. So run experiment there's the fault injection down there at the bottom. So everything else is the scientific method of chaos engineering that you are bringing to the table.
Exactly. Right. So in relation to this, there were some questions around terminology and perhaps how is experimenting different from testing? So when we talk about the traditional ways of testing with integration tests, with unit tests and so on, and how is it different from the experimenting that we're talking about?
I've come across this in talking with customers. Many of the folks who are probably watching today are probably not new to things like software development and SDLC, and they are probably very accustomed to unit testing, integration testing, acceptance testing, etc. But there was a talk that was given several years back, and what they highlighted was that our traditional testing tests what we know. We provide known inputs and we expect certain outputs. The assumption with chaos testing or with chaos engineering experiments is that we are asking a question and we don't know the result of that question. We don't know the answer. And so chaos experiments are designed to figure out what that answer is based on an unknown input. I think that's how I would characterize it.
Yeah, it's important to say that they are not exclusive, right? I think we've done, testing on all sorts of testing is very, very important. In especially to lead to the deployment, and to make sure that we're deploying safe code in deployment. Chaos engineering is testing the interaction between all the service and the product that are being deployed, the dependencies, and then you can't test live dependencies in your test. The only way to do that is using mock services, and usually mock services are not injecting faults, right? So, and that's an idea, by the way. If someone wants to build a mock services that does inject faults, randomly, that's also possible. But really, the chaos engineering is really to see in live in your environment with live condition, the network, going with intermittent errors and all that kind of how those interactions work. And it's impossible to figure out, even to ask anyone to put on the paper what could happen once you deploy something, that's how I see it.
Yeah.
The only thing I'd add to that is that I really like how chaos engineering has brought the hypothesis and the scientific method into it and made it that makes it more palatable and more like tests we know, right? So a simple unit test has a hypothesis to it also. So it is really about organizing your chaos engineering around those hypotheses, which should be based on your design, which should be based on what you expect the turbulence and faults in production to be.
I want to bring on some questions from the chat, not only questions from earlier today. So there's a question here. It's a long one, but let's try it out. I have a question about applying load to the services while running the experiments. First off, is that possible through FIS, FIS, or any other best practice recommendation? And I know, Jason, you use that in one of your examples. I also have that in one of my sessions as well. So, Jason, you want to start out?
So I won't speak to FIS exclusively. In my experience, it doesn't apply load, but that's probably because there are so many different types of load based on the type of system that you're using. So in the talk that I gave earlier, we had a data processing pipeline, and the load there was S3 objects being created. Other chaos experiments I've run have been more RESTful APIs. And so there I was using a third-party load generator, but there's also an AWS solution that will create an HTTP-based, I think Lambda-based load generator, which is a fantastic architecture. So in terms of best practice, whatever your load generator, one of the things that you want to be mindful of is that it is scriptable, so you can bake it into something like your CI/CD pipeline. But the other thing that you want to be mindful of is it applying load in the same way that your clients would, or that your customers would, or whatever is going to consume that service would. And think about that from the perspective of things like timeouts. How long will somebody actually wait for your page to load before they just walk away? And bake that into your load generator, because what you're trying to do with that load generator is to recreate how those users are going to use your system.
Yeah, and I think this relates to the age-old question of running experiments in production or in testing environments and so on as well. That using load testing tools while doing your experiments means that you're able to get a more production-like, at least, environment even in tests, so that you can actually test your services while they are experiencing load.
We wrote a nice use case with Prime Video, actually, because Prime Video does exactly this in production, and they use load generators to create synthetic load on the production system. But because it's synthetic load, that they can, when they run the experiment, it doesn't affect the production, like the real traffic, but it's still within production environment. We wrote a nice blog post. I think if you're interested, really highly suggest you look at it, because it explains a little bit also the reasoning behind having load balance, load generation.
Cool. I'll bring up.
Sorry, just one more thing to say on that. In terms of a lesson that I learned, I started off with a very simple, I think it was a Node.js script, making RESTful calls out from a single box. And I thought that was recreating my user's experience. But when you get down into the weeds, things like DNS resolution are going to be done far less frequently when it's coming from a single box versus, say, 100 Lambda functions, where they're all going to be making things like DNS calls each time on their own. So it is something worth being mindful of when you're trying to recreate that kind of canary type experience.
That's an interesting point, like in that the experiments that we run are simulations, right? And sometimes those simulations are going to be truer to reality and sometimes less true. And we always have to be learning, right? That's an iterative process, is evaluating what's happening in production, evaluating how our systems are responding, and keep tuning and changing our experiments to try to approach that reality.
Yeah, that's a great point, because even though the faults that we inject actually terminate instances or whatever the experiment is, it is still a simulation of a fault in a real world scenario. So let me bring up another question. Perhaps this is a question for me, but I think that counts anyway. So thanks to everyone. To start off, do you have any tips on leveraging FIS in testing an OpenShift on AWS use case? I think there was an example earlier for Kubernetes nodes. And I did an example in one of my sessions with testing on an EKS, instance-based EKS solution, and then killing or terminating containers onto that. And I think you can use the same principle here. If you're running OpenShift on EC2 instances, you can make use of the SSM documents and basically or run commands on your instances to then affect whatever you're running, be it OpenShift or be it EKS or any Kubernetes installation on it as well. Any thoughts from anyone else?
Well, run command is super powerful, and then also SSM automation, systems manager automation is also super powerful. With systems manager automation, you could literally write Python scripts that call the SDK to create your fault simulations in your experiments. So yes.
Yeah, and then by the SSM document, you can actually call the Kubernetes API directly, right? So
actually, that's the way it's made natively intended to be used, and that's actually good too. I guess use Python if you actually have a need for some kind of complex branching or looping or conditionals. But yeah, the document itself can natively call the SDK APIs.
One other thing to add to that, so we talked about different types of manipulations, different types of mechanisms to inject faults into environments as a part of an experiment. And some of the things that I've seen go wrong with other customers when they're running a container orchestration platform in their environment is that platform's ability to communicate with external resources. For example, ECR repositories. In this case, they were trying to spin up a pod, and the node that was trying to deploy that pod couldn't actually pull the image from ECR due to a network disruption. So it's worth, certainly experiment within the cluster and within the control plane and the data plane of that cluster, but also be mindful of what is outside of that cluster and experiment with that as well.
Right, so if you just joined us, this is the live Q&A ending the AWS Resilience and Chaos Engineering Day, and I'm joined by Adrian, Jason, and Seth to talk about resilience and chaos engineering and answer your questions. And we're bringing up questions that have been asked throughout the day, but also questions in the chat, so keep them coming. All right, so there was a question earlier that I wanted to bring up. And when we do experiments, when we do use chaos engineering, how do we validate the end user impact? Open for anyone.
Well, it's part of your steady state, right? I mean, it's going to be part of your hypothesis, right? My system is operating and expected to respond to this many users within this latency, right? So you want to be measuring the end user experience as during the experiment and evaluating that whether that steady state is disrupted as part of the experiment. So that's one part of it.
Yeah, it's exactly that, right? I think a lot of the time the engineers and backend engineers, I speak for myself, right? We tend to want to monitor metrics from the system point of view and forget to monitor the user experience. It's super important to, before you do any chaos engineering experiment, to actually understand your user experience and how to monitor it, and what are the signals that you should look at. Latency, of course, is one of them. Like the client server latency, but it's not all that. It's also like the user happiness. I think there was an interesting blog post few months ago around. I'll try to figure out the link around how do you measure customer happiness, right? That from on your application. It's something we need, like everything. It's something you have to ask the question, and every use case is different, and it might be particular to your application. But it starts by asking the question, working backward from customers and see what makes them happy customers, and then track that. It's not easy. I'm not saying it's easy. But you need to ask yourself the question.
I think I heard this from Casey Rosenthal, who was previously at Netflix, part of the chaos engineering program there. I think he said that the hypothesis that we should all strive for, or the one to use, is basically under adverse conditions, customers are still happy. And I think that's a good hypothesis. Then we of course need to break it down a bit more, but that's what we want.
Yeah, I think it was Casey, actually. You're right.
Yeah. Right. So let me bring up another question. There was a question around when we're using or doing chaos engineering test, do users need to think about informing AWS? And I think this comes from the testing of, stress testing applications. And the notion that you should inform AWS when doing stress tests. Do you see any reason for doing that when doing chaos engineering experiments?
Yeah, so I was looking at that. I'm going to give you a link you could share with the audience that talks about this. So specifically, you have to think about, in general, the answer is no. But what you want to be thinking about, are you going to be using doing some high volume network testing from an EC2 instance? If so, there's a form you could fill out to let AWS know, hey, it's me, it's not an attacker. That's basically what it is about, right? AWS has a lot of capabilities to keep your infrastructure safe, and one of them is sophisticated detection mechanisms that you could accidentally set off, right? And if you set those off, you'll be thought of as an attacker, so you don't want to. So if you're doing high volume network testing, then you need to let AWS know. If you're doing tests that purposely attempt to overwhelm a target, that's actually prohibited. And I should share that link, and that link should be going out on what's allowed and what's not allowed. So if it doesn't fall in that category, then no. Like if you're just calling the control plane to kill EC2 instances, even if you're turning off a lot of them, I think that would be just a normal operation.
Seth, would you care to define high in terms of megabits per second or gigabits?
I would defer to the link I shared, and I don't know if it's not defined there. I'd have to look into it.
Fair enough.
It's the age-old "it depends" answer.
It is.
Yeah, I would suspect that it's not specified explicitly, because I think that the detection mechanisms are sophisticated and we want to keep some of that close to our chest.
Yeah, it's about the patterns as well.
Yeah.
I think the traffic patterns.
Yeah, it's the age-old one person's big data is another person's CSV file.
That's right. All right. So then, Seth, continuing with you, there was a question around the 3 availability zone approach that it's recommended by the well-architected framework. And the question was, let me try to read the question. I've always assumed it was more about avoiding split brain and to avoid running a risk during maintenance window in regards to the using 2 availability zones. And would you agree, Seth?
Well, the 3 availability zones, and the question actually talks about this. I know you can't read the whole thing. It talks about what's a concept we call static stability, which is 2 availability zones is nice, but if you really want to use the reliability best practices, and sometimes reliability best practices are in tension with cost best practices, but you want to use reliability best practices, you should be statically stable. That is to say, if you were to lose an entire availability zone, you still have 100% capacity to serve requests. So with 3 availability zones, you put 50% of your needed capacity in each zone. You lose 1 zone, you still have 100%. With 2 zones, you'd have to put 100% in each zone to be statically stable. So 3 zones gives you more flexibility. So that's the statically stable part of it. The split brain part of it, I'm not sure what the questioner was asking about. So split brain is an issue that if you need to turn off a database for maintenance, or if you lose a database due to an error, that you have a standby that comes up. And during that time, you want to make sure that you basically have data integrity between the 2 if you're failing over and failing back. And I'm not sure what 2 versus 3 zones has to do with that, so I can't quite answer that unless somebody else knows.
Just to add a couple of one thing on the static stability, because I think it's very important, and why static stability is important is when you have an outage, the idea is that your system is already experiencing issues, so you don't want to have to react to basically trying to recover from the outage. You want that the current state of the system handles it without you to have to react. And the 3AZ, like Elliot said, supports that, much better than if you would have just 2AZ, right? So it's like you can handle all the traffic in the subsequent 2 other AZs rather than have to start more instances in 1 AZ to be able to handle the surge of traffic that 1 loss of AZ would give you, right? So you would then handle this. You don't have to handle the surge of traffic, and that's reacting. And reacting is when you have an outage is something you want to avoid. And this is really what static stability is.
Yeah.
All right, Adrian. Continuing with you, then there were, of course, a bunch of questions around FIS and actions and targets and so on. So I'm not going to ask each specific question, but instead let you tell us a bit about the future of FIS, whatever you are able to tell us in regards to future.
Well, okay. So, I mean, I can give you a little bit some ideas of what we're thinking about, right? Of course, we launched a reInvent, and then we've had now a lot of customer feedback, and we start to really realize what customers are asking and want. And then there's really few things that come out is customers want to be able to support what is being called AZ failures, right? And there's not one type of AZ failure, actually. AZ failure is really a combination of small things that put together make your service unusable in a particular AZ, right? So we are really thinking about that construct of what could help customers to model different type of AZ failures and what they look like. And within that in mind, we're also looking at, what are the critical services that customers want when they have this kind of, standard architecture, which has, a database, compute, and maybe some cache, object store, and then the messaging around it and the networking. So yeah, this is really where we intend to go. And having that in mind, we intend to really focus on faults that only AWS can do, right? And really, this is what we call control planes or native control plane faults. Is because this is, I think, where we can provide most value, and help customers recreate some of those difficult conditions that sometimes you get, right? So I expect in the future, this is where we're going, and this is, I think, when you look at customers, AZ failures is in the question we received. There's a lot of this AZ things. So it really reflects the feedback we got since launch, right? So yeah, this kind of thing. Does that answer the questions? Do you want more detail? Where are we?
No, I think that's a good answer. So Seth, let me bring up a question for you that we just received in the chat. It's in regards to disaster recovery. So, is there any solution for active-active disaster recovery scenarios while we're having RDS, not DynamoDB databases in cross-region deployments?
Cross-region, yeah. So cross-region becomes an interesting issue. Of course, DynamoDB has global tables where you could have tables in every region, and you can write to any of them, and they'll synchronize automatically. For RDS, for all of the RDS flavors except SQL Server, you can set up read replicas in other regions. So that gives you the ability to have that data in another region in a read form. With Aurora specifically, Aurora has a functionality called Global Database, where it automatically sets up that read replica for you in another region, synchronizes it using the AWS backbone, which is nice, and gives you automated capabilities to promote that read replica to become a primary in case you need to fail over to another region. So the other thing about Aurora is that it also has a concept called write forwarding. So even though you only have readers in your other regions, they can act like writers and forward back to the primary region. So that's some RDS-based solutions for multi-region.
It is worth bearing that in mind, though, right, Seth? In terms of the active-active scenario, you've got, with any database technology, you're going to have a consistency question. I won't say issue, but a question about how consistency is going to be handled. So in those DynamoDB tables that you've just mentioned, effectively last writer wins, right? Yeah. With the Aurora scenario, where the write will actually be forwarded to the original master, that will be a more strongly consistent write, but there'll be a delay potentially to that write based on where it originated from.
All true. Absolutely. Yeah, there's different models you can look at, which are a little outside the domain of today's topic of chaos engineering. But I have a blog on it. I'll find the link and we'll share it.
Yeah,
just to add to the consistency, because it is an issue. But I mean, if you have a multi-region system, you don't want your client to be going back and forth between regions, right? So you want to make sure that you're using like routing that is forcing requests in one selected region at a time. That's the simplest way to avoid consistency issue and having your client to go back and forth between regions, right? So yeah, in most production systems I've seen, multi-region is rarely an issue at the end of the day. It's mostly an issue when we forgot to think that clients need to continue hammering the same region, and only in a DR scenario you can flip into the other region, right?
I think there's a reInvent talk from 2019 that outlines patterns on this.
My blog links to that talk because it basically draws heavily on that, where they define 3 different patterns for doing writes across regions, and so yeah, absolutely, it's a great talk.
It is, but I mean, and that active scenario that the person questioned, or where they came from the question with, that is a very expensive pattern. But if you, and I as I said when we did introductions, I work with a lot of large enterprise customers here in London, and some of their systems are the most critical to the business. So they recognize that it's additional engineering effort, that it's additional cost to operate in that active pattern, but the RTO and RPO that gives them warrants that expense.
Right. And Jason, while we have you talking, let's continue with a couple of questions around your session. You talked about chaos engineering for serverless architecture. So there were a couple of questions around simulating Lambda cold starts, for instance, and DynamoDB partition throughput limits. Do you want to talk a bit about that?
Sure. So, I mean, with any of these, and these are all great hypotheses, right? These are all great questions. What happens when? And I stress the when versus the if. And the way that you recreate that when is going to vary based on, what the when is. So in those 2 examples that we've just mentioned, cold start as the first one, I think my approach to doing that, there's not a standard answer on this, by the way, at least not that I'm aware of. But my approach would be to use something like a fault injection library. We mentioned failure Lambda. We also mentioned Chaos Lambda toolkit. Did I get the right name on that one, Adrian?
You mean the one I wrote?
Yes, exactly.
Chaos Lambda is for Python, and Gunnar is for JavaScript.
But these are two wrappers that you can put around your code base that would basically stall the execution of the Lambda function at initial start, and to do that just the first time around. Now, that's not an inbuilt capability, but I'm sure both the gentlemen on the panel here are open to pull requests on those libraries. For the DynamoDB issue, my first approach would be taking kind of that Java SDK approach, where you put a request handler in there that simulates or throws the exception artificially. I don't know if FIS is looking at something like this, but what I love about FIS is the work that they're doing with the service teams to be able to inject faults through the control plane itself. Anything so we recently had an addition to FIS where it started supporting, I think, EC2 Spot, Adrian?
Yeah, we just launched actually a couple of days ago EC2 Spot support, so that you can send similar signals that an instance will receive when a spot termination is going to happen, so that customers can prepare the application and verify that it answers or behaves correctly or as expected, because that's an hypothesis, as expected when the spot terminations happen. Yeah, these really kind of directions of faults where we want is really trying to replicate some of those control plane things.
So,
right.
Or even I mentioned about making contributions to things like Failure Lambda. If you're not writing in Node.js, or if you're not writing in Python, shame on you, but there are people writing in different programming languages. I get that. But it's something like that simulation of the cold starts, recognizing when your Lambda function is first starting up and getting ready to execute its handler. This is a fantastic opportunity to start adding your own fault injection code, right? And kind of taking that next step as a part of the chaos engineering journey.
I just want to add as a tangent that the lab I shared with you folks, I demoed, has support for Python, Java, C#, and PowerShell, as well as Bash.
Incredible amount, yeah.
I'm not shaming you here, Jason is.
Yeah, I've always loved that about the well-architected labs, Seth, that so many different scripting options are available there.
Right. So once again, if you just joined us, this is the AWS Resilience and Chaos Engineering Day live Q&A with me, Gunnar Grosch, and I'm joined by Adrian, Jason, and Seth. So if you have any questions around chaos engineering and resilience, keep them coming in the chat. We've got a bunch of great questions so far. So let me jump back into our list of questions. Adrian, there were a couple of questions around how, when you're building your experiment templates, on chaining actions, basically talking about doing them in sequence or parallel. Can you talk a bit about how you from the FIS team see that people should use actions together in a template?
Yeah, it's a good question. It all comes down to, I think, what is it that you want to simulate, and if you look at a little bit the past and what kind of events you've seen, you realize that many outages don't happen because of one fault, right? It's usually a collections of small faults, either happening in sequence, right? And this is typically what you get when cascading failures. So it's a sequence of things. You might have, an increase of latency basically on your dependency, and then because the increase of latency, that increases the number of connection that is being held on the application, and that increases the memory and then the CPU. So you see here I have a sequence. I first have latency, and all of a sudden I can have two actions happening at the same time, which is CPU plus memory. And then you might have other actions, right? So typically an outage is not one fault. It's a collection of small faults happening either in sequence or in parallel. And we wanted to give the customers the possibility to replicate this, right? Typically what we see is, of course, to get, and if you look at the maturity of case engineering, we're still early on there. Case engineering is a new field, and people are still trying to wrap their heads around and get confident with it. So typically we start, with one fault injection and see what's the effect. But I think the goal is really to look at what has happened in the past and try to replicate these in as close as possible to the reality, and you'll see it's really sequence parallel, and this is really the logic we had there behind.
So there also was a question. Just try to find it again. Sorry about that. I lost it in my document. There was a question. Where is it? There we go. Yeah, related to your session, Seth. And how does the autoscaling group know that the availability zone that you simulated that it was unhealthy? How does the ASG know that it's unhealthy?
Yeah, that's a great question. And it goes to the point of, I said during my demo, I said at one point that this AZ failure is the most divergent from reality. The other two are very close to reality. EC2 failure, RDS failure are very close to reality. The AZ failure can't quite get to 100% reality. So the way we do that is we tell it. We literally in the script tell it to take that AZ, specifically the subnets in that AZ, out of the autoscaling group. And that's part of the simulation, which is not exactly how it would happen in real life. So that's one of the places we had to make a little bit of a sacrifice to get as close as we could to make the simulation match reality.
Yeah, and that goes back to what we talked about before, that some things are just really hard to replicate doing these simulated experiments. But that's still close to what would happen.
So if you're going to simulate an AZ failure using the methods we showed you, you actually have to it sort of has to be a little bit bespoke in a way. Like depending on what you're running in that AZ, the script has to know about it. Same thing for the RDS instance. The script literally looks and says, okay, is the RDS primary in the zone I'm failing? If so, I'm going to fail it over as part of the script.
And I would add to this. I mean, these are best case scenario scripts, right? I think having a script not doing the moving of the autoscaling group, is also a possible fault, and understand how your system reacts to this, is also something that you might want to do, because if autoscaling group, for example, sometimes experience an issue and doesn't do that, then you need to be aware, and you need to figure out, how do you monitor that, and can you have like a reaction, automated reaction to this? It's called zonal evacuation, right? And this is something that is very important in part of the monitoring tools. Is monitor some metrics in your AZ, and if you detect like some problems within 30 minutes, maybe the best thing to do is to evacuate that zone. Right? There's an interesting, it's one of the interesting experiments that Netflix was doing with the Kiosk, right? Which were actually evacuating a whole region, right? I think it's an interesting thing to do, and some things fail. Everything fails all the time, so it's one.
Adrian, the memories are flooding back. Like, was it 3 years ago? You in your Git repo, I did a pull request to add something. I forget about this situation where it swapped over the RDS or something like that, and you said exactly that. So what we did is we made it switchable, right? So you can choose when running the experiment whether it does this or not.
Yeah, exactly.
I'm going to bunch a couple of questions together that was asking around safeguard stop conditions. And can we talk a bit about best practices for safeguards when doing chaos engineering experiments, and how to think about that? Adrian, would you perhaps go first? Talk about it from a FIS perspective, perhaps.
I'm not sure I understand the question, so can you repeat?
Yeah, what is the thinking around stop conditions for AWS FIS?
So let's first explain what a stop condition is, right? So we talked about the steady state of the system, and when you make an experiment, basically you want your, the input and output system to be consistent. So that means when you have an input and output, you want that the variation inside the system doesn't affect the output. This is when your hypothesis basically is successful. And when you monitor your steady state, you want to have some margin, right? So you want to say, okay, if my steady state goes above a particular threshold, which is, which was unpredicted, right? So it means that the system has reacted negatively to your fault injection. Your steady state does something that you haven't predicted. This is when you want to say, okay, something is wrong. My experiment is actually doing damage to the output of the system. Let's stop. And this is a stop condition, right? And we materialize that with CloudWatch alarms currently, right? And you could have different stop conditions which are outside of Fizz that call, the stop experiment API for Fizz, but we have this construct inside an experiment where you can define up to 5 CloudWatch alarms, and the CloudWatch alarm can be a synthetic alarms based off different ones. So, it gives you quite enough to look at some of the metrics to monitor if your experiment goes outbound of expectation, and then trigger a stop. This is really the stop condition.
Now, Adrian, we were talking earlier about test environments versus production environments. I think in my presentation, I talked about an experiment is not concluded until the system has, regained its steady state. Are those stop conditions, should we use stop conditions in a test environment, or are those withheld, and do you use those primarily for the production environment tests?
So my opinion is we should always use stop condition, because if you start by not using them, you'll get familiar and you'll get used to not using them, which I think is a bad practice. And actually, you had mentioned load generation and things like this. These are great ways to actually validate that your stop condition works as expected as well in a test environment before you put stuff in production, right? So we talk about the Kiosk experiment, but you need to validate your CloudWatch alarms before you put them in prod and make sure that actually they work as expected, and that they detect the system's variation as fast as you expect. I think a lot of people think that CloudWatch alarm can be triggered instantly if something goes wrong, but it really depends on how you set them up, and doing this in test or staging environment helps you tune that, and then as I say, it's tuning, because you're going to go back and forth trying to figure out what's the best setup for you, and this is very, very important that you always think about the stop condition.
Okay.
My opinion.
To feed that back to you, you've got a steady state load being applied to the system. You apply some stress to it. You inject a fault. You then observe it for some period of time, and if none of those SLIs breach, if none of those alarms go off, then you kind of time out and you carry on and wait to observe whether things come back to steady state. You remove the stress and wait for steady state to regain. Or one of those SLIs does breach, in which case you prematurely remove that stress and then wait to observe the system back to steady state.
Yeah, and this is also one possibility. I love, and we don't support this currently in Fizz, and it's very hard to do it, but I love to do Kiosk experiment using what's called a canary deployment, where you have like 99% of your traffic going to one environment, and then 1% of your traffic going to another environment, which is a replication of your, exactly the same system, but you inject the faults on only one of the canaries, right? And so that's your control experiment versus the Kiosk experiment, right? So that you can really see in real time the effect on the steady state. Because of course, if you monitor your steady state at instant t, and then you inject fault, and at instant t+1 your steady state change, and you do that on the whole environment, you don't really have a control group, right? To look at, to compare to. So ideally, really, what you want to do is find ways to have some part of the traffic directed to an environment where you can do your Kiosk experiment, and you can do this with DNS routing, Route 53. You can do this with an application load balancer with target groups. You can do this with API gateway. You can do this with Lambda functions. This for me, this is really where we should aim to go, to really make sure that what we do is there's a control group and then the experiment group.
And that goes back to the scientific part of chaos engineering as well, because that's how you often do experiments in other fields.
Correct.
And this is something that we've seen example of how Netflix uses that with their, is it called CHAP?
CHAP.
With using control groups. I want to circle back to the stop conditions, Adrian. Would you say that you should use the alarms that you already have in place for your environment? Would that be an optimal way of doing it, to make sure that these are the alarms that you already have for your steady state, for your environment?
Well, it all depends on what are the current alarms you have. And I say, frankly, from all what I've seen, typically people tend to focus on alarms which are really system metrics. And for me, that's not what steady state is, right? A steady state is really a combination of business metrics and system metrics. I always take the example of Amazon, which is orders per second. This is really important to understand what is the right metric for you to measure, right? We talk about video providers. Their business is to deliver video. So having the number of time people click on the play button is a good metric, because it gives a user experience feeling and also like a system indicator of an issue. If you have to press 10 times on the play button to get your movie, or if you don't get your order in the time that you was expected, that's an impairment that impacts user experience. So that's for me what steady state is. And if you have these in place, then yes, you should use them. If you don't, then don't only focus on on system metrics, which is typically CPU, memory, TPS or stuff like that. I think it's important to think outside the box and really look at the overall system. Does it answer your question?
That brings us back nicely to, I think, well-architected, right? One of the things about well-architected that I know, having done well-architected reviews with customers, that can sometimes catch application delivery teams out, is you ask them, what is the business value of the application? And they don't know. They're not connected with that part of the business. They were asked to go off and build, widget X, since they are building a widget and it looks like an X. So it's a great learning exercise as well, to understand what are the business metrics for the system, whether it's reports generated, or whether it's files processed, or anything of that sort. Data set discovery, if it's a data catalog system, there's it's going to be different from system to system, but understanding what the business value is of that system is very important.
And that ties back to what we discussed at the beginning, right? Is like what the value of chaos engineering is, the before and after. And typically it's increased communications, right? And because you discuss about your hypothesis, you discuss about your system and the business metric, and and this is what, for me, what I've worked in the last 6 years with AWS customers. And the most value I've seen in customers using chaos engineering is typically this kind of soft skills, so increased communication between teams, and therefore, because you have increased communication, it just works and improve culture and all that kind of things.
We're reaching end of the show shortly, but I want to bring up a question that perhaps this is something for you, Jason, based on what you do. How can we elevate the practice and principles of resilience and chaos engineering to regulated bodies, especially in financial sector, to help to address the issue of single cloud risk and help us avoid having to engineer for multi-cloud?
Yeah, and this is one that I encounter a lot in terms of working with regulated industry. Regulators are pushing more and more, putting more and more pressure on especially financial sector firms to improve and not just improve, but also demonstrate their operational resilience. So there's a lot of interest on behalf of these firms now on how to demonstrate resiliency. Historically, this is something that firms might do once a year. It might be a tabletop exercise. And with things like chaos engineering, we're talking about, automating your testing pipe, automating your testing as a part of your CI/CD, or putting in chaos experiments and/or chaos tests to repeatedly demonstrate that if 1/3 of the system goes down because of static stability, we've got the ability to continue operating as if nothing had happened, because we can take the excess load on the other 2/3 of the system. And that is not something where historically firms have placed a lot of weight and money and time and effort. So it is something that is becoming more aware to regulators, and customers are picking it up and learning it to run with it. In terms of the multi-cloud piece, I don't feel that, and this is my personal feeling, I don't feel that regulators are necessarily asking firms to demonstrate that they can run a system in cloud A on Tuesday and at cloud B on Wednesday. They recognize that there's not necessarily parity between the clouds, and that it's not a whimsical thing to do to run a system here and then there, that there's a lot of time and engineering effort that is required in order to make that happen. But being able to demonstrate that you've got the expertise, that you've got a plan and a strategy to execute if and or when you needed to go from cloud A to cloud B is worthwhile. And that brings us back to tabletop exercises. So I think I've gotten a little bit off topic, but operational resiliency from a chaos engineering standpoint, I think, is something that is starting to pick up and is starting to get visibility both within the financial services firms as well as within the regulators. And then more operational resilience in terms of longevity and business continuity is also starting to pick up, but I don't think it always gets interpreted the same way based on who you're talking to. Sorry, very long-winded answer.
No worries. All right, so last question was directed directly to me from Dominic. Are there any game days workshops for FIS and chaos engineering? And in terms of workshops for chaos engineering, we have the one that Seth showed us in his session earlier, and also the one Jason has created around serverless architectures. They are available in the session links. Perhaps if you are quick, I can paste them in the chat as well. Otherwise, there are a couple of new workshops that will be launched during reInvent, and they will be publicly available as well after that, using FIS in the workshops. All right. So with that,
actually, the workshop is available already. The FIS workshop, just FYI. Yes.
All right. So it is available at workshops.aws, I think, is the place to find many of those. All right. Links to share. So with that, there we go. I'll paste that. With that, I want to thank Jason, Adrian, and Seth for joining me. I want to thank all of the viewers for joining as well. And everyone who's been with us all day, great job. It's been a lot of sessions on quite intense topics. So great job. Right. Thank you all. And I hope to see you at our next event.
Thanks, everybody.
Thank you very much. Bye-bye.
Bye-bye.